table and punch in negative 2.1, and you will see you will get a positive number. And if you punch in negative 1.9, you see you will get a positive, what did I do? Yeah, I'm sorry, yes. So that's the positive and that's the negative. And that's what we got.
Okay.
Now, if you want to graph this function, but don't copy, please don't copy the graph from the graphing calculator. You need to put in the horizontal asymptote on your own. 1 divided by 8. And because it's such a small number, you have to adjust the viewing window because you're not going to be able to read this. Okay, so negative 1010 loses its point. So just negative 5 to 5 will be enough. With a scale of 1, that's okay. Or y minimum, I would not go lower than maybe negative 4. But y maximum, in order to see that horizontal asymptote, because it's so close to the y-axis, I will just put also 4. Just because I want to see that horizontal asymptote. So let's see, because it's at 0.125. Okay? So the calculator is lying to us. You notice that this piece, so let me double check what I entered. That's correct. So this piece, when it graphs it, it appears that it even goes over, well, it does go over the over the x-axis, but it appears that at some point in time is the same line with the horizontal asymptote, which is not the case. So if we want to zoom in here, you'll see what happens. So if I go back to the viewing window and I'm only looking at y between negative 1 and 1, then we'll see better, much better. See? So the function does not become the horizontal asymptote. It cannot do that. So this is the horizontal asymptote, and this is the function. It doesn't overlap with this, and it doesn't overlap with that either, of course. Is that, and of course, don't forget the vertical asymptote. The calculator doesn't graph it. Is this what you meant? Is this what the question was about this?
Yeah, that's my question.
Awesome. So is there anything else that we need to go back to?
No.
Of course, all these, this will require way more time. Way more time. However, they're not really asking anything here but just the horizontal asymptote. But graphing for such a function will take way more time. But for this, in this section, they only, I mean, in this portion of the exercise set, they're only asking to, for this, for example, they're asking everything. But for these functions that are way more sophisticated, if you want, they only want the horizontal asymptote, which means you only need to determine the limit at infinity, or limits at infinity, depends. That's all you need. Good. Anything else you would like to go back to? Anything else? Is there anything else from here? So this was the graph and this was a max-min. So if we're given another function, we will always determine the max-min by finding the critical numbers and then studying the sign of the derivative. Here, there were no critical numbers, and I had to study the sign of the derivative. I realized it was always positive. So then this function has to always increase from 1 over 8 to infinity, from negative infinity to 0, and to 1 over 8. Oops. I hope you saw what I said, what I showed. Okay, we still have a few more minutes. What would you like to go back to?
Can you do one of those ones where it's like find dx over dt when like x is this and dy over dt is this?
Yes, so this was this. Is that what you meant?
Yeah, where it has like multiples in there.
Yeah, do you want to choose a problem? Do you have one for us? Any problem?
I don't know if there's like a random problem. I don't have one though.
So that is in 3.9. 3.9 is on page, no, implicit differentiation is 3.8. Sorry, so 3.8 is on page 359. 359. So let's choose. Is this what you had in mind?
Yeah, one of those.
With dp over dx? Any problem? You wanted the related rates, or you wanted just implicit differentiation?
I think it was related rates.
Okay, then it's on page, sorry, 364. 364. We did in class 16, 18. I remember this from last time. Now you choose whatever else you want from here.
Maybe just 19 then.
19, very good. In 19 we have a squared equals b squared plus c squared. Everything is positive, and we are telling us dA over dt is what we are asked to find when a is 13, b is 12, dB over dt is 0.25, and dC over dt equals 2. Perfect, perfect pick, thank you. Okay, so I know we have 2 minutes if you need to leave after 2 minutes, but I have to continue and finish the problem, so forgive me. I may need more than 2 minutes. So all we have to do is differentiate. Obviously, this says that a is a function of t. This says that b is function of t, and c is function of t. That's why I put a dot under each. So 2a dA over dt equals, I don't know why I put that over there, 2b dB over dt plus 2c dC over dt. So they're asking us to determine dA over dt so I'll simplify both sides by 2, and I will write that dA over dt equals all this, b dB over dt plus c dC over dt over a. And all I need to do now is just put in those values. So b, 12, dB over dt, 0.25, c, I have to determine c, dC over dt, 2, over a, 13. Okay? And dC over dt. Good. So in order to determine c, I have to solve for c. So c squared equals a squared minus b squared. So then 13 squared minus b squared will be our c squared. So 169 minus 144, and that is 25. So then c squared equals 25, or c equals 5. And now I have to punch this in the calculator. Careful how you do it. Put parentheses around the top. 12 times 0.25 and plus 10, and I divide by 13. I got 1.